Hi, my name is Grace Drew, and this is my public lecture to the study of transitioning planets. So, the first question we are asked is, what did I learn? So, first of all, there were a couple definitions I was unclear on going into this. Firstly, being what is a transiting planet? And those are basically planets moving in front of a star. Um, and this will have like a certain look. And this study was the first attempt in finding planet B, which we'll get into a little bit later. Another definition I was unclear on was what an exoplanet was, and this is a planet that orbits a star other than the sun. So planets are stars in our solar system, but planets that orbit stars external are called exoplanets. Uh, so in order to discover transiting planets, planet B, the brightness of star versus the function of time is measured and graphed, and this graph is kind of like a spectra of sorts. Um, Ideally, your graph will look like a box shape with a small drop in brightness and a flat bottom light curve. This will be an allusion to the fact that you might have a transiting planet. There's also the possibility that there are contaminations, so two stars, a star being in front of it, being in front of another star versus a star being in front of a planet, and this will look more V-shaped than the box shape that you want. What did I already know? So, cyanobacteria are responsible for discovering photosynthesis and reengineering our atmosphere. Um, this was a big revelation in modern biology and really reshaped the way that we think about natural selection and development. And this was really crucial in studying life on other planets, as certain gases present in the atmosphere can lead to the belief that there's life on other planets, especially because cyanobacteria were capable of reengineering our entire atmosphere. There's definite possibilities for life on other planets. Was there something that sparked your curiosity? So for me, the ability to find atmospheric composition via modeling wavelength of light and the amount of light blocked in the atmosphere was really interesting. So this was another graph that she showed us, and it was also a spectra of sorts. It looked a little bit similar to the one she showed us to find transiting planets. But this basically is something that they're able to do from the Earth and take the wavelength of light that is basically shined through and the amount of light that gets blocked. And via the graph, they can discover, what gases the atmosphere is composed of, and that also helps lead to discover what types of life could be present on other planets. Did this relate to your major? So not specifically. I don't do a lot of stuff with things outside of the Earth. Um, but I did find it really interesting because the graphs shown were somewhat similar to NMR and IR spectras. And in chemistry, we use those a lot to study the composition of substances. And it was really interesting because she had the two types of graph, one which showed transiting planets and the other which shows the composition of the atmosphere of the planet. And that's kind of how we use NMR and IR hand in hand to really get down to the details on what a substance is composed of. So this was very similar. Did I follow up on this topic? The speaker recommended The Hunt for Planet B, and it's a documentary